capacity for gravel is almost around 500 kPa. And there's another characteristic susceptibility to the frost action. So we can see the gravel is no vary about to the frost, the winter and something gravel is none. And another character is this one is permeable for the water, the drainage. So gravel is excellent. So after gravel is sand. Sand size is 0.05 to 6 mil. And sand, the bearing capacity is almost the gravel, but it's less. It's half the gravel capacity, bearing capacity. And for the frost action is almost the same, is slight. Because they have the smaller size, they have some water inside the ratio, water ratio, so they have a slightly action to the frost. For the permeability to the water is not good sand. For the gravel with fence, that means the gravel with some soil, the mixed. This is the poor for the drainage. But the sand, the clean sand, we see the clean sand, the capacity is good, is excellent. And for the permeability to the water is excellent. So the sand. So from this table, we can get the reason why in the Richmond, we have the foundation and we always layer the sand for the subfloor. We use the sand bed to underneath the foundation, the footing. So the sand. After sand is silts. Silts, the capacity is the middle, so it's only the 25% of the gravel. And for the frost action is medium. For the another one, drainage is not good, is poor, but it is still okay for the mostly the foundation, the subfloor. And the last one is clays. The clays is sticky, because they have the more water ratio. So the bearing capacity is only the 2000 is only 1/5 of the gravel, and the drainage is very poor. This table is general information for the soil. This soil classification is based on the ASTM. Is a unified soil classification system. It's basically used North America use this system to classify this soil. This is general speaking. So this, we just have the picture to show how the soil reaction to the load and the test for the soil capacity test. The top picture is show the reaction. So when the foundation have the load to press to the soil, and the soil have the reaction to the foundation. That's just a picture showing that. And another picture is shows how to test. So when you have the sample, the soil, so I want to know what's this soil capacity. So they have used the test. This test is a standard test. There is just have some to blow that one to hammer, so the stand hammer to you will see the how differential for the this sample the soil and how many times the hammer to hit that one. That's just this test is usually go to the sample from the site and go to the library to have the test. This picture shows how is still the action for the soil. So this just shows the soil embankment. This is the angle for the repose for the soil. That means the soil have the more capacity. They have the more compact. They have the more bigger angle for the repose. For example, the top one is a compact clay, and for the saturated clay, they have no angle for repose because there is no compaction. So, for example, the sand you cannot have the angle. They just have the layer, the horizontal layer. You need the compact that one. You need the fall to resist that sand layer. Just dig the trench, you have the sand. Here we will just describe some slope protection. Sometimes when the site is sloped, so the slope, if you have the very large slope, because it have the water, if we have the water rain or water rain off, there's erosion for the slope. So we need to protect the slope. There are several kind of way to protect the slope. The first one is a very natural one. It's just some grass, the plant. You can some use the organic things to naturally protect the slope. But that one, the slope is big, that one doesn't work. This first one. The second one is show if the slope is steep. So we need to have the gravel and have the sand and combined or mixed to protect the slope. The third way is commonly used is retaining wall. Because we use the retaining wall, we can have the step make the slope profile change to the step by step. This is why we use the containing wall. The very commonly and typically used is reinforced concrete containing wall, because we use the concrete retaining wall. We can have the more height to protect the slope and have the step. This is just the general shows how to design the concrete retaining wall. Basically, the wall, we will think about the pressure for the soil and the moment. So for this retaining wall, if the soil have the load, the pressure have the moment. So this wall will be turned this point. But we have this retaining wall have the weight. They have this weight, so we will get the balance and get the weight balance. That's the way we design the retaining wall. There's several kind of the retaining wall, and the retaining wall we commonly use, frequently used is a T-section. Why we use the T-section? Because we need the button, have the big button to have the fraction. Fraction, that means we have the fraction, they have the weight to produce the fraction. So if we have the load, they cannot move. That's the way we use the T-sections. But in some special case, if another side is property is another neighbor, you cannot use the T-section because you have the leg to go to another neighbor property. So sometimes we use the L shape. So there are some different kind of the retaining wall we used. For the top one is a T-section. The middle one we have still the T-section, but we have the cantilever wall because they have the long way. Because, for example, the highway is we need the very long retaining wall. So in the middle, we will build the wall to support the retaining wall. And the bottom thing we talked before is for the property. Some property is adjacent. So we involved to leg to go to another property. We use the L shape, but the L shape is not good for the retaining wall. But we just have no way we use that. Retaining wall is this is just the typical section for the retaining wall. Retaining wall we need the reinforced, so we have the bottom reinforcement and the vertical reinforcement or the horizontal reinforcement. This is just the typical. We have the example to show that we did the project for the. This is another kind of the retaining wall. This is not the concrete. It's just use the local material. For example, in the mountain areas, we have a lot of the rock. So this is an economical way to build the retaining wall. We use the rock. We shape the rock, and we have the cement. Layer because this rock is very heavy, so we use the heavy load to produce the fraction. onto the button. So that works. But they need wider. For example, this one is 400 millimeters, 1 feet, 4 inch. So sometimes depend on the height of the retaining wall, we maybe have some more button wide. That kind of the retaining wall is commonly used in the mountain area, in some river and. This is a typical project we did before in the Burnaby. The Burnaby, we have the image for the Burnaby. We have the hue profile for the site. We have the creek, they have the river and something that. This one, this guy want to, this is a slope, very slow. This guy want to, this one get the flat site. So they need the, build the retaining wall here, and so the backfill will have the flat site. This is just for example, is before. So this before is the plan and elevation for show. This retaining wall is complicated because this side they have the city property. So this side is an L shape, and this side is another property. So this side is a L shape, but we need the long way. This side is a T shape. That's complicated. There's a typical section detail here. So it's made before this. Because we use the reinforced concrete retaining wall, we have the height is almost 2 meters, 7 feet, 7 feet, 2 meters high. This project is complete. It's I think that's all for the soil and slope protection and retaining wall. This is just keywords for this. If someone has a problem or you have some comment, just we can discuss or talk this. Yeah, that's the soil. So we continue. This is for the soil. So after that one, we'll discuss the structure loading. So structure loading is very basic for the structure design because the architecture is give you guys the room, but the structure need to support this room. That's the structure function and here. And the loading is basic for the structure to resist. The loading is two kind of the loading. One is a static loading. Another one is we just classify that one. The static loading is the first one, and the dynamic loading is the second one. What's the static loading? So static loading is assumed to be applied to slowly to the building, right? And until it reaches the peak. When they reach the peak, the the loading is get the peak magnitude, right? And the static loading is we can divide it to several kind of the static loading. So we will get familiar with the dead load and the live load and the dead load, right? So dead load is a static loading. It's to act vertically to the structure and compressing the self-weight and self-weight and the structure member weight, they combine together is a dead load. The live load is basically is for the people, right? Because the building is for the people, so the live load, the majority load is for the people, for the furniture, for the equipment. And there's another one, live load, is a snow load. This is snow, right? Snow load, green load. So the dead load and the live load, we can calculate according to the location, according to the environment. We can. And there's another one is dynamic load. Dynamic load is sometimes it's dynamic load means the suddenly. It's not slowly. It's suddenly applied to the building. So I will ask the question, what kind of dynamic load you know is a very typical dynamic load?
No.
Yeah, earthquake is seismic because it is sudden. No one to know it. You cannot calculate it. Everyone cannot. Is a complicated dynamic load. Another one dynamic load is wind load, right? Wind load is sudden. Right?
And people, the residents' activity is the live load?
Yeah.
The people's activity in the room.
Moving. The static load, the live load is means moving.
Yeah.
You moving. Another dynamic load is for the we can calculate. It's not complicated. For example, the pump, right? They have pump, so they have the dynamic load. Sometimes you can control it. You can have it. You know when to happen, right? You have the power, so they have the dynamic load. So, but the seismic is hard to.
What is the pump load?
Pump is dynamic load because they have the move vertically. Yeah, just works vertically. Pump, the equipment.
Yeah,
equipment. Yeah, but the pump. But it depends on the pump the capacity, right? You can change it. You can control it. This is one kind of the dynamic.
I can't understand.
No.
So when the pump is working,
sometimes for the industrial they have a pump house, right? The pump house.
Oh.
Yeah.
You mean commercial project.
For the pump house, we have the special foundation.
Okay.
Because we have a spring to balance that load. We see the live load is movable, right? Because of this room, we have the meeting, so we have the more live load here today. But tomorrow, we don't have. That's the live load. But we just have the average. We have the average live load.
Second.
This is the wind load. Wind load is a dynamic load. It's a kind of a dynamic load, but it's not complicated with like the seismic load, but it's a dynamic load because we don't know one is get bigger or one is disappear. The wind load is there's two action to the building. They are depend on the shape your building, right? If we have this building is a typical building, so the wind blow here this way, right? This it can be any way, but this is just the example. Go to this way, but this side, this face is a pressure, right? And the wind goes that way. This roof is can be pressure or suction, depend on the angle. If the angle is bigger than 30 degrees, is a pressure, but is less than 30 degrees, is a suction. Yeah. And another roof is suction, depend on the angle, same thing. But for the back real face is a suction. So pressure, suction. Yeah, that's the wind load. Wind load. So the basically the angle is a 30 degree. Yeah, depend on the angle. This is a earthquake load, seismic load. Is very complicated, yeah, because that one is a sudden load. The earthquake load is basically is a horizontal load, but it can be any direction for the earthquake load. This is just the general speed. There's scientists to do something for the earth load. It's complicated, yeah. There's a table is for the if we design the building, depend on the which city you do. So every city, because they have the different location, right? So they have the different environment date, or we can call it design date for the structure design. This is just this table is varied from time to time. Every year, they just based on the previous year, they will update this table. Yeah, we can get this table from all the city hall. The first table is from the, I guess, the Bernard. Yeah, Bernard. So they just showing the basic information for the environment, for the rain load, for the snow load, and for the seismic load. Yeah, the last one is seismic load. So SA, SA means, right, the spectral acceleration. This is the time. So from the time, shorter is bigger. This is just for the seismic design load here. There's we always concern of the snow load, right? Because in the winter, if we have the deck, or we have the flat roof, they have a lot of snow. So snow if they get the longer to not melting, they will get snow will accumulate layer by layer, and they will compress and compact. Compact snow is very heavy, very heavy. It's like the soil something. Yeah. So the different city have the different snow load. This is a Burnaby. Burnaby, we have the snow load. Ground snow load is 2.7 kPa. Yeah. It's 50 psf. 50 pound square feet, right? Square feet, 50 pound. You see, very heavy. But the snow load, when you design the roof and design the structure, is not. They will have the discount for because it's not every day have the snow. We just have the short time. It's winter, something, December and January something. Summer, the fall is we don't have snow. This is a Coquitlam, city of Coquitlam, and this one is West Vancouver. Yeah, just generally speaking. This one we can get this one from City Hall.
Is the snow load different from Burnaby and Coquitlam?
Yeah.
What is the difference?
You see the ground load one, the 50 years, the 2.7, right?
Yeah.
We can see the Coquitlam is snow load. Yeah, Coquitlam is they classify that one depend on the elevation.
Oh.
So more elevation, high elevation, they have more snow, right?
Okay.
You go to the Gross Mountain, a lot of snow.
Okay.
So for the 400 meters, they have the ground snow. Where is ground snow? Yeah, it's a 5.7. It's a heavy.
What is the lowest of?
Lowest is a 2.6. Right?
2.6.
Yeah, it's a 0 elevations.
So it's similar to Burnaby's.
Yeah. Okay. So that one, West Vancouver is same thing. Or we can compare it for the 50 to 100 meters. So the 2.66 Coquitlam is three. So Coquitlam is bigger. It's almost same. 2.6 and 3 is almost same. Yeah. It's just a little bit different. This one is just for the. I think we more concerned about the snow. The seismic we don't know. We don't know. So for our majority for wood construction, for our residential wood construction, it is excellent for the seismic load.
Yeah.
Yeah. It's because this seismic load is more seismic load depending on the mass, your weight. But the wood construction is light, so we don't have the more seismic load. The more seismic load concern is for the high building, high rise, right? For the high rise, you will see that for example the high rise they like this, right? If you lower, nothing. That's the basic.
Yeah.
So that one we will discuss the loading. So we just keywords, right? Static load, dynamic load. For the static load, it's a live load, dead load, right? Just basically that one. And snow load, we concern the snow load. So we complete this description and we'll go to the building structure. Talk about the building type and building type and characteristics. That one, I think that everyone get familiar. That this is a reinforced concrete frame. It's not the concrete; it's a reinforced concrete because they have the rebar, yeah. So this is a kind of the commonly used for the high rise, for the commercial building. We reinforce concrete frame, and this is just a typical one. We based on this one, we have the reinforced concrete shear wall construction. Also, we have the reinforced concrete tuber construction. Yeah, this is all the reinforced concrete building. That one is we can have the, because we can have the get the more height, more width, and more room. And also they can resist kind of the seismic. This is commonly used the steel, structured steel construction. We use the steel. This is different. Why we use steel? Because with steel we have the more span, more room. Also, we steel is light compared with concrete. Steel is light. Another advantage is that steel the concrete, the reinforced concrete, there's a disadvantage just for the season, for your construction time. It is limited because in the winter, we can pour the concrete, we can have the foundation, that one. But the steel, we don't worry about the season. Every day we can have the steel construction, yeah. Because of the steel construction, we can have the steel fabricated in the shop.
Factory
And,
manufactured.
and fabricated in the shop and shipped to the site and reinstalled. So that one, but the concrete doesn't work for the concrete. Yeah, this is an advantage for the steel. But the steel, there's a disadvantage is expensive. Yeah, compared with the concrete. Yeah, I'm not sure here, but there's compared in China because the labor cost is not big. So here, labor is very big. The concrete has more labor. Because the steel, we have the shop fabrication. They use the less labor. That's the advantage in the North America. Yeah. Yeah, this is another kind of the structure steel construction. Yeah, the use the open web joist. Yeah, we have the more span. This is commonly used for the superstore and the Walmart something. They use this one. Yeah, to because they need the more room. They need the more span. So it's the only way to use the steel construction. Yeah, the wood construction doesn't work. It cannot span huge like the open web steel joist. So this is a wood construction. This is average. So I think the builder is do most for the residential building house. This is a wood construction. This is just a picture. I think everyone is get familiar for this one. Just to classify that it's a wood construction. So we concrete, reinforced concrete, structure steel, wood construction, and there's someone is a combination. It's more used, and this is a wood and structure steel combination for that one. Because the wood, they have the give you some feeling for the wood feeling. Someone want to have the wood feeling. Someone want to have the steel shape. So there's a combination for the wood and steel construction. A lot of building right now, there's some commonly used for the wood and steel construction. Because, for example, this building, we have the because the steel frame, we don't the wall is not the barren wall. The wall can be any shape. But if the wall is a barren wall, you can the opening, there's a limit for the openings. There's more restrictions. But for the steel and the wood construction, this for the wall is no barren wire. So they can have any shape. Also, they have the roof. They can have the any shape roof and have the more span for the roof. So this is a different kind of give you the different shape and different vision for the house. So here is we just generally talking about the building type. It's not all, it's just basic types and some advantage and disadvantage. So after that, let's discuss the building. The building, there's we will before we talked the loading, right? So the loading is from top to the bottom. So now we will discuss the loading transfer, loading transfer. So this picture is just showing the building load transfer from the floor to the beam, from beam to column to the pad footing. Yeah, this is just a loading transfer. The structure design is to design the structure, have the loading transfer properly from the top to bottom is a two things. Is a loading transfer is properly and the clearly, right? So some design have a problem is the loading cannot transfer. Yeah. So the loading if cannot transfer, there's a problem. So the design is get clearly and properly transfer to the from top to bottom. For the building, there's a kind of the member. The commonly used we know the column. The column, the beam, the floor, flanks, and the roof truss. Column is to resist the vertical load. Yeah. So the column is a primary member and a very important member because the column is need to transfer not only the vertical, sometimes the horizontal load. This is just show the load is axial load. The axial load is a central load. Sometimes the load is not the center, so they will get a shift to load. So this is just the reaction and the deformation for the beam, not the beam, the column. So when the column have the vertical load, the axial load, they have the two reactions. One is bending, right? They have bending. If the capacity is over that capacity, the beam is rigid, but they will bend. Another one is buckling, right? They will turn. So the beam, the reaction is a bend and a turn. That's the two action. Yeah. But when the column is buckling, they feel. So we have the limit. We have the degree limit for the column to buckling. Just showing the column have the restriction for the end restriction, right? End restriction. They have the different restriction, different support for end support. They have the different actions. So basically, here we will see the restriction. Basically, we only have the two restrictions. One is called the end connection, right? End connection. One is a pin connection. Yeah. Pin connection is a simple connection. Yeah. Just for example, they have the column here, they have the beam here. It's just attach. It's a simple connection. Yeah. Another one is a moment connection. Yeah. Pin connection, we cannot transfer the moment. Yeah. They will freely. And the moment connection is a fixed connection. You can see this one is fixed connection. So the column is almost half they can use to resist the load. But this pin connection, they will shift. That's the why we, for example, we see the light column, the straight light column, they have the base, very big base here. Base is for we have the bolt, right? Bolt. If we only have the two bolt, is a pin connection. Doesn't work. They cannot, because that post have the moment, right? They have the moment. So we usually you see the 4 bolt. 4 bolt is a moment connection, so they can resist the moment. Not
Moment connection. Can you explain in Chinese what is moment connection?
固定制作。
Oh, moment.
Yeah.
Oh, okay. Moment.
弯曲。So the post, right? The post, they will action like this. Action like this. If the pin connection, like that one, right? If you have the moment connection, they have the relationship with your base. The pin connection almost no relationship. We'll talk that one is later. You see here. This is a beam. The beam reaction. Beam reaction is same with the column, right? The column is vertical, right? Beam is horizontal. So if you lay down the column, is a beam. It's easy to read. So this is a reaction for the beam. Beam is same thing. If you have the distribute the load here, the unique load, right? They have the band, same thing, band, and the buckling turn, same thing. Right? Deform is a buckling is deformed. Is a fail. Is a doesn't work. It cannot. That means if you see the beam is torsion. They have torsion here. Is a buckling. They cannot resist. They cannot add the load anymore. This is a beam. Almost with the columns, just horizontal. So here is a moment diagram. This is a diagram based on this is just for the calculations. Generally speaking, just give you guys some information for here. This is for the engineer, basically for the engineer. Yeah. That one is a cantilever beam, right? So this side, this is must be the moment connection, right? If the pin connection like this, have the moment connection fix the support. So they have the very big moment here. This is a no moment, right? It's the end, no moment. Here, for example, they looks like a bridge, right? They have bridges. They have the deadman here, support. So they have load. They have the distributed moment. It's another thing is continue the beam. They have the moment diagram. Yeah. It's just some information. This is a truss. The truss is like the beam, but they have the member. They have a member to pin connection together. They have a pin connection here. So that if the truss we have the more span. Use the truss, not the beam. Yeah, because it's a hollow. It looks like they have this plate here. We just remove here. It's a truss. It's another beam, truss beam. is a rigid frame. That's we're talking about the moment connection here. Is because there's a rigid frame. They have the deform is different. Yeah, because they have the moment connection everywhere. So they have to resist the more horizontal force. So we use the rigid frame to resist the horizontal force. This is the planks for the to arrange the planks for the roof, for the floor, to resist and distribute the load. The floor system is the flank. We can see the one way and a two way. Yeah, just general speaking. So it is a one way, just sitting on the bearing wall here. This is sitting on the beam. So they have the two way to transfer the load. Two way transfer the load. Load to this beam, load to this beam. This is still the one way and the two way to transfer the load. How do you know the one way or two way? So the simple is for the size. So this size and this size. For example, this size is 2 meters, and this size is 4 meters. It's double this size. Is for sure 100% for sure is one way. So the load not transfer this one, just transfer to the bearing wall here or beam here, because this is a size, depend on the size. If the size is even, 2 meters, 2 meters is a two way. The load is always like this, like I think the electrical. Electrical, if you have the two wire, one is shorter, one is long, they go to short one. Same thing, loading, they always go to the short one. But if the two direction is the same, they even. That's the way to know how is one way or two way. This is just table. Is a sum the span, how much the span they can, the flanks, they depend on the joist and the decking and the open web joist. This is just general speaking here. We can see the very big span is for the steel, right? The open web joist, they have more span. They can span 90 feet. Yeah. Also, we not commonly use. We want to the more span. We can use the precast. The precast, we have the precast teeth. We have the more than 100 feet. Yeah, that's the precast. Yeah. There's something we want to focus on the lateral stability. What's the lateral stability? Because that one, we have every beam. That one beam itself is no problem. everyone, beam and column, everyone have no problem. They can transfer the load properly. Everything load we transfer from top to bottom to the foundation. It's no problem. But the building still failed. Why? That's the stability. Because that one, every system is no problem. Wall no problem, is a flooring problems, column beam no problem, but they need to stability. For example, that one, if we have the member to not put the bracing, they will no stability. That's lateral stability. For example, this one, the frame is no problem, everyone is no problem. But if they have the lateral load, for example, the wind or some dynamic load, they will fail. That's the stability. So we need to add another one to have the stability. That's the very important for the for the building, for the structure. We have several kind of the way to add the stability. So commonly used is a brace. We can see the using the tower. You have the tower. You have the bridge. So they have some diagrams. That one and the scissor. You can the scissor something. Why? That is a stability. It's not to transfer your vertical load or the horizontal load. It's a stability. So there are some kind of a lot of the joint, a lot of the connection for the member, structure member. That one is just general speaking, there's some typical connection here. Basically, we have the connection is, for example, for the structural steel, we only have the two connections. One is like the moment connection. Another one is your pin connection. Also, we have the for the moment connection, we have the two. One is a bolt connection. We can, if you can see the bolt connection, is a bolt connection. Another one is a welding connection. Why we use the bolt connection? Because the bolt connection is, if structure steel is fabricated at the shop and go to site, ship to site and install, we need the bolt connection, right? Also, we can have the site welding connection, but the welding connection very expensive. The bolt connection is very simple. It's just go to site and to install that. I think if you have experience in the IKEA. IKEA, the furniture, everyone is have the bolt connection. Yeah, that's easy. You can DIY it. But the welding connection is sometimes we need that one. The bolt connection doesn't work. For example, the tuber, the steel tuber, they have the oil gas. The gas have the more pressure. They need the bolt connection doesn't work because they can leak. But they need the welding connection. This is the welding connection. The bolt connection can be the pin connection, can be the moment connection, depending on how many bolts you use and how to arrange the boat. Yeah, that's the a lot of thing. This is just general speaking. There's several kind of the connection here. Yeah, there's use some strong tie here, and the welding connection, and the pin connection, and the precast concrete connection. Yeah, that's it. It's for the building, for the load distribution, for the characteristic of the column beam, and we have the connection. Yeah, typical connection. Have the question or?
Yeah. Can you tell us how much is the cost difference between like steel construction,
Steel construction?
Yeah, structure and wood framing and reinforced concrete. Like only in small building, in single house or part 9 constructions.
There's a lot of things because it depends on the building. For the for example, reinforced concrete, that one is not usually is for the commercial or for the high-rise building. For the residential building, we don't except the foundation. We don't use the concrete.
Okay.
It's concrete is more side work. You need the reinforcement. We need the post concrete, the labor cost. But the wood construction is cheaper. Because the material is cheaper. The construction labor is cheaper.
Okay, let us think about the single house in Vancouver West, like UBC.
Yeah.
Yeah, we know lots of single house was built in, steel, construction steel structure, right? Yeah, what is the cost difference between these buildings in UBC area and built in construction steel structure or wood framing structure? Yeah, to these two kind of
depend on the style. Depend on the building. Building itself, the architecture. Sometimes the different shape, they have the different cost. Yeah. And
can you give us
generally speaking, the wood is cheaper.
Yes.
For here,
yes.
Wood is cheaper.
Yeah,
because,
of course.
The material is cheaper.
Yeah.
And material easy to handle. You don't need a crane. For the steel, and it's expensive. But with steel, we can have the different shape.
Okay.
Yeah. This is general speaking. And concrete, I think the concrete is basically for the basement, for the foundation. That's it.
Yeah.
For the upper structure, steel or combination, steel wood combination.
Okay. Okay, we can only think about 2 buildings in UBC area. One was built in construction steel structure.
Yeah.
The other one was built in wood framing, normal wood framing. Yeah, the similar size, similar floor area. So what is the difference of the construction cost or who can tell me?
Yeah.
2-3 times
Pardon?
more expensive.
More
2-3
expensive,
times, 4 times.
4 times.
But
At
you
least-
don't put the concrete everywhere. Some decoration, some walls and the ceiling in the contemporary design, you would do the
Yeah.
concrete.
So if we build a house in wood framing in UBC, like the construction cost is like $400 per square feet. Then the other one, which was
You
built
cannot
in.
say like, can I?
Yeah,
You cannot say like this, because the place you put the concrete is a basement and some feature walls in the contemporary design. And the steel you just used for bigger span, you should not cover with the wood
Oh, okay.
beams.
Yeah, I understand.
Yeah.
So,
You don't put the floors with the concrete, you don't put the ceiling with the concrete in the residential.
okay.
You don't need it.
Yeah, so some areas.
Some areas necessary.
We shall use steel,
Yeah, steel and
but
concrete.
but the other, the main building we
With the
only use wood
This,
framing.
this kind of building, a lot of in the West
Yes.
Vancouver, right?
Yeah.
Because they want to, they have this side, they have view.
Yes.
They want to have the good view here.
Okay.
And also they want to have the different shape and
Yeah.
just a very clear shape here. This building looks like the Germany. They have a lot of building like this. It's a box, but they have the good view here. So this is about steel and wood construction. I don't think it is costly. Costly,
It's
yeah.
too costly. Okay.
I don't think so. Yeah, because this very clear, very simple. The steel column here, beam here. They have this side you can have the wall. Every wall you can have some fabricated some material. It is not very expensive.
You know why I ask this question? Because one of my friend, he ever asked me, some people told him, then build a single house in UBC area. The construction cost normally is $1,000 per square foot. But the same size built single house in Vancouver West, like Dunbar area,
Yeah.
or some little bit in, we only need 300 or 400. He asked me why. I couldn't answer him. So that's why today I ask you.
Probably they depend on the internal.
Internal decorations.
Yeah, decoration, the ceiling, and they have the. For this one, just for example, this steel and wood construction can be costly, can be cheaper. Why? Because it's column, right? This column steel, the common steel is cheaper. But if you use some
Special customer.
yeah, customized. Also, you use the aluminum. Someone they have the columns. They have some covering, right? The coating,
Yeah.
different. That is very
Curve,
expensive.
some curve.
Yeah. That one is depend.
Okay.
UBC里面房子一般也比较大，有14000尺的地，本身就建房子6、7千尺，然后它本身设计的就是房子比较大，另外一个就是
Also,
检
this
查特别
wall,
所以它
wall
在你的
panel
概
here,
念里面，它的
wall
那
panel
个
can be the wood,
成
can be
本
the
大概是
aluminum,
多少
can
钱
be
一尺？
the
知道吗？
glass.
要看，
要看
That is different
会要到
price.
1000块钱一尺，
So
有点高
depend.
了哈。
depends. Yeah. You can have this one very
对，我也觉
cheap.
得，
For example,
对，
you
我
have
觉得
this
400-500块钱我可以理解，但
100
是要是
per square feet,
1000
you
多块钱
can
一尺，我就
500
觉得
square feet. It's the same thing, still cheap, but
比较简单。其实你说的那些，它只是把一些部分。
I'm not focused on the cost, just for the structure, for the
对
design,
呀
for the
所以好，
function, for,
Okay.
for,
谢谢。
for the load transfer. That's it. For the safety, yeah. So the engineer focus on something. So we'll start at the foundation.
设计费10几万，设计费任何一个10几万。
This is the foundation engineer.
Chinese
Yeah, the
designer，
foundation is
中
a
国人
basic thing.
中国设
So
计
the
师。
foundation is
全是老外设计的，现在
will support the upper structure and transfer the load to the soil.
后来现在有
That's
些中国的设计师可以了，现在
very important. So foundation, basically we have the two foundations, generally speaking. One is shallow foundation. Yes, shallow foundation. For example, the shallow footing is commonly used the Richmond. The Richmond we cannot build the basement, so we use the shallow function, shallow foundation. Another one is a deep foundation. So that this one is a deep foundation. Deep foundation means we have the basement. The basement can be one layer, or 2 story, or 3 stories. Depend on the height of your building. There's some simple way to, so if we have the high rise, they should have the foundation, right? They should have the deep foundation because they need the deep foundation to is the embankment, right, to the earth to resist your horizontal loading, seismic loading, yeah, wind loading, something. So, for example, my high rise is 300 meters high. You know how to know we need how many meters the basement for the 300 meters high rise.
Only 1/10.
Yeah, 1/10 is 1/10. So we need the 30 meters basement. This is just the general speaking. This is our foundation to transfer the load, and after the loading is applied to the structure, and structure and the transfer load to the foundation to the soil. There's a very important thing is the foundation can be settlement. They have the settlement. Settlement means they get the deeper and deeper because they have the load. We approve some settlement. The only concern is uneven settlement. If you uneven settlement is access to our limit, the building will fail. This is just showing the differential settlement here. So depend on the building, the width and the length, they have the limit for the differential settlement. also they have the settlement differential settlement is for the, because they have the settlement, uneven settlement, the concrete wall will crack. They have the crack. The crack, they have some limit for the crack, depend on the building type and the building degree. Some very important building, they have the less the crack.
Limit.
Yeah. If that building is for the president, for the VIP, they have the more degree for the assessment limit. This is another kind of the deep foundation is commonly used. For example, in the West Vancouver and North Vancouver, there's some building like this because they have the step for the profile for the step. We don't ask weight everything there, but we use the different foundation here, the deep foundation and the shallow foundation. We don't need to excavate everything here. So we just use this kind of thing for the economic reason. This is an underpinning of the foundation. There's a lot of things, a lot of kind of, we need to underpinning. Why? Because we for the renovation, some building before is a bungalow, but we need to have another 2-story. We have another story, so they have the more load. There, the existing foundation is doesn't work. We need to stabilize the old foundation, so it's underpinning. There's several kind of underpinning for the foundation. This is general speaking. This, I think the builder should be focusing on some excavation support is shoring. In some area we need shoring. Yeah, for the North Vancouver, for the West Vancouver, we need shoring. Yeah, there's a city need your provide the shoring plan, shoring detail for that one, because that one is costly. That one is means the shoring means you
Money.
put the money
Shoring means money.
in the earth. Yeah, you cannot get any profit. Yeah, shoring. Why they need shoring? Because the house is 1 by 1. If you build your house here, the neighbor will complain. You excavating have the big hole there. How about my basement? They complain. So the city to protect the neighbor, so they need provide the shoring. This is a shallow foundation. This is a commonly used for the Richmond. So here is some combination here. With the foundation, we have the combination. Shallow, we have the deep foundation, we have the shallow foundation. For example, the basement, the internal wall, we have the shallow foundation, right? And the external wall and the perimeter wall is a deep foundation. So it's a combination. This is just to show you the combination. Also, we have the pad footing middle, so this is all the combination. For the high rise, the reinforced concrete frame, they have the different combination. They have the column, they have the slab, they all the combined together. Yeah. This is a foundation wall. We commonly use. This is a foundation wall, another foundation wall. This one is used for some crown space. The crown space, in the crown space, some crown space is very high. It's almost 1 meter, 1.5 some meter in the surface. So that one is use the concrete wall. It's not the shallow, it's a middle. It's not the deeper foundation, but it's not the shallow foundation. It's a foundation wall. It's use the crown space. This is a common foundation wall. I think the builder is get familiar with this. This is not commonly used. This is a 40 years ago and 50 years ago. We usually use the concrete masonry wall. That one is not used. It's because they cannot resist the seismic load. That is poor. It doesn't work for the seismic load. This is a typical section for the foundation, and there's some steel plate and some framing relationship and hold down. Yeah. I think why we need the hold down. Hold down here, right? It's a plate. The plate is embedded to the concrete. So they have the plate to nail to the wall. It's usually in the corner. Every building, 4 corners. They depend on the shape. There's a complicated shape. They have the more corner, right? So every corner, basically, we have the hold down. Hold down is a seismic. When the seismic load coming, the hold down is very important. There's a different result if we have the hold down and without hold down. Yeah. Also, the hold down is to resist the lifting, the wind. The wind will get the building lift, right? Gust wind.
Okay.
So the very important.
Something like the moment connection, right?
Yeah, it's yeah. We can see the moment connection here. It's because it's a bend to the concrete.
Yeah.
The concrete is very heavy, so
Yeah.
the uplifting for the wind, the uplifting is heavy. So also accept the hold down. There's anchor bolt, right? Anchor bolt to sail plate to anchor to the concrete. Yeah, we have the anchor bolt for all the wall, external wall and inside wall. This is a typical section here. Concrete wall, steel plate, bolt. That we have the joist. We have the rim, right? They have the wall here. This is very typical. this is another typical connection. For example, the basement if we span is very much. The wood beam sometimes doesn't work. We use the steel beam. We design the steel beam from this wall to another side wall. So the steel beam, we need the pocket. We cut the concrete. So when you design this one, they pour the concrete, they need to the pocket to sitting on the steel beam or wood beam. The same thing, yeah, steel beam. Another thing is we use we need the more span. For example, the basement is for some hall. You design for the cinema or for some game room. You need more span. So we use a steel open web joist. That one we can have the more span. This one is sitting on the concrete wall. This is just general speaking for the cell. Another kind of the connection here. It's a very common use. That's still the foundation wall. This is the column footing or column foundation. It's a single foundation. We call it the pad footing, right? The pad footing. If the porch, they have the two posts, so we use this one. Or if you in the middle of the house, they have the more span. If we have we need to put some columns in the middle of some beam, something. They don't need the strip footing, just use the pad footing. Yeah. This is the pad footing for the steel column. This is for the wood, for the porch. This is for the concrete. There's some, if your site is sloped, so the footing is we need the step footing. Yeah, those step footing. For example, if your basement is a sloped one, but we need the basement have the window, right? If the concrete wall is higher, is a flash top, we cannot have the window here. So we step the footing. Yeah, this is very common for the slope site. This is a concrete grade. This is a very common concrete grade. Just sometimes we use the concrete for the concrete slab. We still use the reinforcement here. Usually we use the net, the steel net. Why we use the steel net? That one is not for the load. It's just for the to control your crack. Yeah, control, because for the temperature change, they will shrink. The concrete will shrink. Also, they have the span. Shrink span, have the crack. So we use the steel. This is a concrete slab for the basement. They need a control joint. The control joint is the same thing for the control the crack, control the shrink and the expansion, control the shrink and the expansion. But for our house, because we have the footing middle, right? But they separate the slab, so we don't need some control. For the big house, we need the control joint. It's still the concrete slab. Just quick. This is some slab penetration, because sometimes you bury some tuber inside. For example, they have the heating tuber or ventilation. There's some penetration. This is a pole foundation. The pole foundation is a wood column, and they just bury to the earth and to support the top floor. This is very common for the deck, because if you have the deck there, you don't have wall here. Just use the wood. This one is we can call it the deep foundation, and there's another one is still the wood pole foundation. Yeah, it's just bury the wood. They have have the pole the concrete. Why they put the concrete? Because they protection the concrete, protection the wood to not rust. Yeah. Also, we have the correction, or we have the more weight to settle the pole. Very commonly used deep foundation is a pile foundation. The pile foundation is very commonly used for the commercial building, high rise. Also for the if your soil condition is very poor, is some silt, dirt. Also in some areas, underwater is very high. This time, the excavation cost is very heavy, or doesn't work for excavation. So we use the deep foundation, pile foundation. So the pile foundation, the design is drill the pile. The pile can be two kinds of. One is a concrete pile. Another one is commonly used steel pile. Steel pile is a steel tuber. So they hammer the pile to down to 2 meters, 3 meters, and 10 meters. Go to the bearing, or have the bearing capacity soil or rock. That construction is the hammer. If you hammer, sometimes cannot hammer down. That one is okay. So it's hammer everyone. So they have the pile, concrete pile or the steel pile. They have the concrete cap here, and they have the concrete pile here. From here, you can build every foundation here. You have the columns. Column can be the steel columns, can be wood columns, can be the concrete columns. That's the basic pile foundation. This is a pile foundation. Different pile foundation is steel. This is concrete. Why they use the concrete? Because the concrete is cheaper. Concrete, just drill the hole and put the reinforcement and pour the concrete. but is the same thing. The steel, concrete cannot do it winter. Yeah, but the steel can do it every day. That's the, but the cost is different. Yeah, this is a concrete, right? Drill the hole, have the reinforcement, have the concrete. Yeah. There's a combination here. The drill hole, put the steel, put the steel column, and have the concrete. Just put the concrete. This is commonly used for the shoring. Shoring is used this one. Yeah. The steel, the casing foundation is a concrete pile foundation. This is commonly used for the bridge, for the heavy load structure. This is steel and concrete pile for the shoring. Yeah, this is a basement we did before. There are several, just typical here. So there we excavate the basement, have the form, the form. We have the reinforcement here, and we have the form this way. Pour the concrete, put the anchor bolt. Yeah, we have so that's the basic basement deeper foundation construction. The rebar spacing typical is 14-inch, both way, 40-inch, and 40 inch horizontal and vertical. Yeah, we usually use the horizontal bar is a 3 bottom and the 2 is top. Yeah, this is another side. This is have the form. Have the form and ready to pour the concrete. Yeah, that's all for the foundation. I think we can take the rest. Let's just have the rest. TGI is a floor, the wood flooring. There's the concrete reinforced slab, the flooring, right? This is the concrete flooring. There's a steel. Steel is open web, the steel, and we have open web joist sitting on the column or the wall. We have the deck, the steel deck. Steel is a plate, steel plate deck that sitting on the joist, and we put the concrete. So that is the steel deck concrete flooring. Also we have the steel deck concrete flooring, or the steel deck flooring. Yeah, there are several kind of. This is a steel. This is a concrete beam and slab connection here. We have a reinforcement here. Just quick. This is we talked before. Is one way slab. Slab is one way slab or two way slab. Is we talked before. It's one way or two way. So there's a slab. There's a beam. Right? This beam slab would be one way or two way. This is another kind of the concrete slab. Is very small beam, narrow beam here. So we have the more spec. We use concrete slab. Same thing here. This is another construction for the concrete. Is the concrete we don't use the. We use the take slab. We don't use the beam. We just have the column and the slab. That's it. So that one is usually used in the mall. In the mall we don't use. So they have the clear ceiling, right? They have clear ceiling. So that's another kind of the construction, concrete. This is a special. It's a precast concrete. Yeah, that's we for the residential we never use this one. This is a very big span. For the bridge, right? They have the tone, the bridge. We use that one. We need that one. It's still the precast. Precast the basically is if load is vertical is this way, right? They have the shape upward. So they if have the load, they flat. This is a concrete form shoring. This is we not commonly use. Now this is a structural steel framing. Yeah. Structural steel framing is common. Is a steel column, steel beam. It's the same thing. Yeah. And they have the special base connection. Is a bolt connection here. Depend on how many bolts you use. Depend on how much load you apply to the building. This is a structural steel frame. This is steel beam. The steel beam is commonly used. This is an I-beam. It's a W-shape I-beam. It's very common. Yeah. Also, this is very cheaper, but is very function for the I-beam. Why we use I-beam? For the wood, we cannot have the I-beam, right? The wood, the steel is like this. They just remove the middle portion. That one doesn't work. We don't use it, but we save the steel. That's the I-beam originated. This is several kind of the steel construction connection. Steel structural steel connection is huge, a lot. There's the different shop have the different connection. They can be the bolt connection. They can be the weld connection. Yeah, this is all the connection. This is some span for the open web steel joist. We talked before. This is open web joist framing. Yeah, This is a commonly used for the mall. We have the open web frame. This is some control.